In your daily life, you might think a very simple decision affects only you. But the truth is, it's not that simple. This is exactly where the idea of parallel universes comes in. But where are these parallel universes? Let's say they exist somewhere. How do they emerge? Assume we answer that too. Then how can we reach these universes? In this video, we make all these questions more concrete. A small choice you make might change not just your path, but the flow of everything around you. Especially in the quantum world, where all possibilities can exist at the same time and overlap at a single point, it's almost impossible for the idea of parallel universes to escape the attention of physicists. According to doctoral theses on parallel universes that are accepted by scientific committees, the claim is that even a simple decision might lead to a completely different version of you in another universe. And that's not all. These theses also suggest that there could be a twin of you in a parallel universe, and that your decisions in this universe might actually affect that version of you based on quantum theory. For those of us squeezed into tiny homes and narrow streets, even imagining another city, a different country, or even another planet often feels out of reach, so you're probably asking, what does it even mean to make a parallel universe feel real? That's exactly why we made this video contrary to popular belief. The idea of parallel universes is not new, and perhaps not so surprisingly. It first appeared in ancient Greece in the 5th century BC. Democritus and Epicurus proposed that countless atoms move randomly through space, and that this could create an infinite number of worlds. It sounds unbelievable. But this was their claim over 2,000 years ago. Fast forward to our time. For the idea of parallel universes to stand on solid scientific ground, we first needed quantum theory to develop. And then the concept of superposition had to be introduced and proven experimentally, because the principle of superposition is one of the foundations of quantum mechanics. And it is the direct starting point for the idea of parallel universes if we want to understand parallel universes. We first need to understand superposition. This principle entered the world of science in 1926. With Erwin Schrödinger's wave equation, Schrödinger's equation showed that a particle, instead of having just one specific value for position, speed, or energy, can exist with multiple possibilities at once. In other words, an electron is not located in just one place. It can be in many places at the same time. This idea of being in multiple states at once contradicts our everyday intuition, but it has been confirmed again and again through experiments, and that became the first real scientific foundation for the idea of parallel universes. It's hard to grasp, but when an electron is in superposition, it holds all possible positions, states, and motions at the same time. It's like a bundle of possibilities created by overlapping wave functions. It may sound strange, but this is a real feature of nature, not just a theory. It's an experimentally proven fact. In fact, from laser technology to MRI, from quantum computers to GPS, many of today's technologies are built on the principle of superposition. So yes, we already use superposition in our everyday tools, but does that mean? There's one part of this that really challenges the human mind. The moment of choice when an observation is made. When we measure the electron, the system makes a decision. Only one possibility becomes real, and that's the one we see. But what about the other possibilities? Where do the rest go? Are they erased? Do they just disappear? This is where things get even more interesting. Some recent theoretical and experimental studies suggest that the possibilities we don't observe still exist as wave functions. In other words, even if we don't see them, they might still be there. Somewhere by 1957, physicist Hugh Everett introduced a groundbreaking idea to explain this mystery. It was called the many-worlds interpretation. Everett proposed it in his PhD thesis at Princeton to solve one of the biggest puzzles in quantum physics, the measurement problem. According to Everett, when a measurement is made in the quantum world, like checking the position of an electron or measuring the spin of a particle, the universe splits to include all the possibilities in the superposition. So, when you open Schrödinger's box, in one universe the cat is dead, in another it is alive, and you only experience one of those outcomes. But that doesn't mean the others are gone. It just means they continue to exist in another universe. In fact, recent work shows that the wave functions of unrealized possibilities do still exist even back then. Everett's idea was radical. His interpretation said that every measurement, every decision, every quantum interaction creates a new version of the universe as a result. In a universe with infinite possibilities, there are also infinite branches of reality. So how does that happen? How does the universe split, first of all, while the realized possibility continues in our world? We already know that the wave functions of the other possibilities keep going, Hugh Everett says. When you measure the spin of an electron, the universe splits into two copies. One with spin up, one with spin down. Now imagine you're standing at a fork in the road. One path goes to the right, the other to the left in classical physics. You choose one, and the other is simply never taken. It remains in the past, unrealized, but in quantum mechanics, under the many worlds interpretation, the moment of decision becomes much more fascinating at that exact moment. The universe seems to split. One version of you turns right. Another version of you in a different universe turns left. Both outcomes are real, but each one happens in a different universe. In fact, that decision creates a new universe. At least according to the theory, this unbelievable situation is like a universe-sized reflection of one of quantum mechanics' key principles, superposition. Normally, a particle can exist in many states at once, but when you observe it, you only see one outcome according to the many worlds interpretation. None of the possibilities vanish, and all of them continue to unfold. In their own separate universes, that part is only theoretical. There is no experimental proof for this. Yet according to these theories, every decision you've ever made might have caused the birth of an entirely new universe at this point. The obvious question is, were all these infinite universes the answer? Is that they are believed to exist in a mathematical space called Hilbert space, and they're thought to be stacked or layered on top of one another physically. We cannot access them. They are truly parallel, just like possibilities in superposition, existing at the same time, but never interacting. So what is Hilbert space? Hilbert space is an infinite dimensional space that contains infinitely many vectors. It allows for length and angle to be defined, and it works with complex numbers in simpler terms. Hilbert space is a mathematical space used in quantum physics to hold all possible states of the universe. Everything we know through quantum theory is described and defined within Hilbert space before you observe an electron. Its entire existence, with all its possible states, resides in Hilbert space. An observation takes one of those possibilities out of Hilbert space and brings it into our world. In summary, Hilbert space is the mathematical shadow of our universe. Quantum theory itself is defined inside this space. So if you're asking, can we communicate with other universes in Hilbert space? Theoretically, no, because these universes are not connected through quantum entanglement. At least, that's what Hugh Everett suggested. Also, at the moment of a decision or measurement, the wave functions of all possible outcomes, separate from each other. That's why, in theory, communication is not possible. Think about it this way. We can't even communicate with a planet 1,000 light years away. So it makes sense that connecting with a different dimension inside Hilbert space would be much harder. Another common question is this: let's say you decide to go left, and your twin in another universe goes right. Is that twin's past the same as yours? The answer is, theoretically, yes, but after that moment, your futures will slowly grow apart. Another interesting question is, are these universes truly physical? Or are they just possibilities? If we say they're physical, we have to imagine an enormous multiverse where every possibility actually happens. Scientists haven't observed these universes directly, but quantum computer experiments and particle physics research have started producing results that mathematically support this idea. Some rumors even say that the incredible speed of quantum computers comes from tapping into other universes. We couldn't find a confirmed theory about that, but the core idea is this: the power of quantum computers might come from running multiple possibilities in parallel across different versions of reality. But according to the many worlds interpretation, communication between those universes is theoretically impossible. Still, the idea is exciting, even if we have no confirmation. Yet another question people often ask is the other version of me really me? The answer is both yes and no. Your version in a parallel universe might be nearly identical to you in memories, personality, and genetics, especially if the split happened after a very small decision, like choosing coffee instead of tea. But over time, those small differences grow. You meet new people. You take different jobs 5 years later. That version of you might no longer feel like you at all, just like how the person you were 5 years ago is not exactly who you are today in that sense. The other you is still you, just shaped by different experiences. Here's another big question. Did those parallel universes already exist? Or are they created by your choices according to the theory? They are created at the moment of decision. Before the decision, they don't exist. The act of splitting creates them, but this has nothing to do with human consciousness or will every time a superposition collapses. A new universe is born. It happens at the quantum level, whether we're involved or not. And what about a central universe? Is there one true original according to the theory? No, the idea of a main or side universe doesn't exist. From the point of view of each observer, their universe feels like the center, just like in general relativity, where every frame of reference is valid. And finally, people ask, when or how could we prove these universes exist? If they exist at all, that's a very difficult question, but if we could ever bring a large-scale quantum system into superposition and stop its wave function from collapsing, we might witness the moment of branching. However, in macroscopic systems, decoherence happens extremely fast, so observing that moment would be incredibly difficult. Are there any experiments looking for proof? Yes, in 2018. Researchers from Oxford University searched for signs of parallel universes. By measuring quantum stability, they suggested that just like we now detect gravitational waves, we might one day detect parallel universes if we can improve our quantum measurements to an extremely sensitive level. But so far, no signals have been detected, and that brings us to the end. Today, we try to make the many worlds interpretation a little more tangible. See you in the next video.